This is the beginning of calculus, section 1 of chapter 3. There you go. So what we'll be doing now is learning some faster rules for differentiation. For instance, you might look at this problem and say, I don't really know how to do this problem. But what you could do is rewrite it by FOILing it out, like 2x times x squared, multiplying by every one of these. So you're looking at 2x cubed, it'd be minus 4x squared plus 2x. But then don't forget to distribute this minus 3 to everything. So minus 3x squared plus 6x minus 3. So again, I'm just rewriting f of x. Let me rewrite it one more time, because you wouldn't want to do each one of those pieces, because you can combine negative 4x squared minus 3x squared, that's minus 7x squared, 2x and 6x is 8x, minus 3. So then when I ask for the derivative, this is very straightforward. You can bring the 3 in front, which is 6 is 2 times 3, x to the second, minus 14x plus 8, and the derivative of negative 3 is 0. Now, what we can do, well, they want you just to remind yourself what f prime of x represents. So think about that. So as a reminder, this is the slope. This equation will find you the slope of a tangent line at a given point. All right, so think about that as we move forward. But what I'm going to show you is, first of all, this notation is typically what Newton used. And what you need to familiarize yourself is with different notations. And a man named Leibniz also came up with calculus. So you have Newton and Leibniz who developed calculus. And what you could do is actually you could write it in terms of f of x as two different functions. Maybe I should use h. I feel like I should use a different letter than what's there. So I'll use h of x is equal to, now I'll use the functions f times g. And what one of these two men, I couldn't tell you which one, they found out that the derivative of h is equal to the derivative of f times g, that's a times right there, plus, then you leave f alone, times the derivative of g. So what I'm saying is if you look at this same exact problem without distributing, because maybe you're afraid that you're bad at distributing, and you're asked to find the derivative, well, what you can do is find each individual derivative and then plug it in. So hold on a second. Well, how about this? Let me rewrite this problem as h of x so it matches what we had up here. So let me call f of x that 2x minus 3. And if I asked you for the derivative of that, I hope you would tell me very quickly that that derivative is 2. And if I look at the other function, call that g of x, x squared minus 2x plus 1, and then that derivative would be 2x minus 2, I'm making the conjecture that the derivative of this function, which I'm well aware that I'm rewriting it back as f, but just stick with me, is our problem says take the derivative of f, which we found was 2, and then times you leave the other function alone, x squared minus 2x plus 1, and then plus, now you leave the first function alone, that 2x minus 3, and then times the derivative of the other, which I actually witnessed while grading these tests this summer, like students writing this out, which I have never seen before. And they would write it out and draw arrows and just match things up like that. Or I forget exactly how they matched up the arrows. Because it's a derivative of f times this. Yeah, that's what they did. And then the derivative of this times that. So they did like an x. Anyway, it was goofy. So my conjecture then is that if you distribute here, it'll be equal to the original problem that we started with at 6x squared. So let me show you that. As you distribute 2x squared minus 4x plus 2, and then here as we FOIL, you get 4x squared. The outside would be minus 4x. The inside would be minus 6x. And negative 3 times 2 is 6. And as we combine like terms, you get 6x squared, negative 4x minus 4x, negative 8x, negative 14x, and 2 plus 6 is 8. Lo and behold, this value is the same thing as up here. Now you might be sitting there and say, well, I already knew how to get that derivative, so why would I spend this time learning a new rule? Well, we have that because what if we have a scenario like this one? Is it possible for g of x in this problem to distribute in there and find that derivative? And that answer is simply no. So I don't even show all that work that I had earlier. I just write it out to help you out. What I do is this, and I think it's very helpful, is I put 4 blanks down, plus, just like this. And I just think to myself, okay, this first blank is the derivative of the function to the left, which should be 2x. Now you leave sine of x alone. And in this blank, you leave the function to the left, which is x squared alone, times the derivative of sine, which is cosine of x. And you just found the derivative of that very complicated problem using what is called the product rule. Maybe I should emphasize a little bit more. Why do we call it the product rule? It's because you have a product and you have the independent variable to the left. That would be x. And you have an independent variable to the right of that product. Because you might have been saying earlier, well, we did the product with a constant. You know, let's say if, I'm not done with this problem, by the way, but let's say you had a problem that was like, I don't know, p of x equals 3x to the 4th. This is not the product rule because where the product is, there's not an independent variable to the left. This is just your typical power rule. So that's like a little thought bubble that has nothing to do with this problem. I just wanted to identify why this is a product rule, because of the product right there in the middle. So back to our problem. This is the correct derivative. Now it's asking you to find the slope of the normal line. Think about what that means. Well, the normal line, first is you'd want to plug in what the tangent line is. So it's 2 times pi times sine of pi. If you're confused where I got pi from, it's right there. Plus pi squared times cosine of pi. Well, think about where pi is on the unit circle. That's a half revolution. That order pair is -1, 0. So sine of pi is 0. And cosine of pi is -1. So the tangent line has a slope of negative pi squared. So what would the slope of the normal line be? It's the opposite reciprocal of that, because remember the normal line is perpendicular, so +1 over pi squared. All right, feel free to pause this video and re-watch anything. You know, it's not a race. Take good notes, make sure you understand before moving on. So we're practicing more product rules here, and if you do this like I would, I mean, as you get more practice, you probably won't draw these lines out, but I do think it's very helpful, especially for first-time learners. Could you FOIL this out? This is a problem that you could, FOIL out and then do the power rule. But we want you to practice the product rule. So the derivative of the first function, again, notice where the product is. The product is in between those two. So the first function would be 4x plus 3. Leave x squared minus 3 alone. And then leave 2x squared plus 3x alone. And then the derivative of x squared minus 3 is 2x. Now at this point, could you simplify that? You could simplify. But remember, in calculus, they do not require you to simplify. So we can stop right there. I wanted to share, though, the answer key if anybody were to try and FOIL that out, and you can see how messy it gets. And I don't think it's advantageous to spend your time, especially when it's not part of the grade. They will never ask you to simplify and get the best answer. Now, if it is a multiple choice question, they might require you to match the correct answer. Whatever they did to get that answer, your answer might need to match theirs. That would be my only advice as to why you should know how to get there. So that's why I'm sharing this with you. And you probably already noticed on the next problem how they point out how the square root of x, as a reminder, is to the 1/2 power. And so when you identify that product is right here and you find the derivative, it makes perfect sense that the first derivative is 1/2 x to the negative 1/2 power. Leave x squared minus 3x plus 2 alone. And I don't have much room, so I'm just going to write it directly underneath. Plus, leave that x to the 1/2 power alone times the derivative of the next piece, which is 2x minus 3. So for our purposes, this is good enough, but that's about it. So this is another problem that if you wanted to, you could have FOILed it out, or it's not FOILed, just distribute it out first and then take the derivative. As we look at the next problem, this is definitely a product rule. Here's your product. You have a function to the left, a function to the right. That's what I mean by that. So the derivative, I'm not going to write the lines now because I want you to get in the habit of really understanding. It's a derivative of x cubed, leave sine of x alone, plus leave x cubed alone. The derivative of sine is cosine of x. And this is good enough. Again, as you go off to college and maybe take a similar class to this, your teacher might ask you to factor out an x squared. So you're looking at 3 sine of x plus x cosine of x. There's really no benefit of doing it in my class, though. So here's another problem that if you wanted to, you could, it just would not be advantageous. Let me put it that way. To distribute cosine in there. Just do the derivative of the left side, which is 3, leave cosine alone. Now I actually wait to write the plus, and you'll see why in a second. Leave 3x plus 2 alone, and then the derivative of cosine is negative sine, and that's why I would wait to put the plus sign. So this is your answer. As you get really good at this, it becomes second nature, trust me. So we throw this problem at you to recognize where's our product rule. Well, if you look on this left one, it's not technically the product rule because the derivative of 3 theta is just 3. Now this piece right here is the product rule where the derivative of theta is 1. You don't have to write it, but I will. Leave sine alone. Plus leave the theta alone. The derivative of sine is cosine of theta. And this is it. By the way, I guess I should mention that some teachers teach it the opposite, like leave alone, take the derivative, leave alone. Well, addition and multiplication is commutative, so it does not matter. All right. So here's another one, sine of x times cosine of x, where the derivative of this, well, if you do this, and I do want you to simplify this one, because the derivative of sine is cosine, leave cosine alone. And then plus the derivative of, well, you leave sine alone, and the derivative of cosine is negative sine. So what I would like to see in this problem is that you recognize that that's equal to cosine squared minus sine squared. And that's the best answer. All right. I don't want to rush through the next problem, so I'm going to pause it right here, upload, and start a new video shortly.